Welcome to the deep dive. Today, we're going to be diving into humanoid robots.
Okay.
Specifically, a proposal for a next generation HR that kind of goes beyond what we've seen before.
Right.
We're talking about a robot that's not just programmed to perform tasks, but one that actually mimics human senses to interact with the world.
Yeah.
And we've got a research proposal outlining this ambitious project and the CV of the lead scientist, Dr. Samuel Neymotin,
Okay, great.
to guide our deep dive.
It sounds fascinating. I've had a chance to glance through it, and it really does seem to be pushing the boundaries
Yeah,
of robotics and artificial intelligence.
for sure.
The core idea here is to create an HR that can actually perceive its surroundings using a very similar sensory framework to us humans.
Okay.
So vision, hearing, touch, and even smell.
Wow. Okay. So they want to build a robot that can basically see, hear, touch, and smell like a human.
Yeah, that's the goal.
That sounds straight out of science fiction.
It does. It's very ambitious, but the proposal lays out a pretty compelling case
So what's the rationale?
for this approach.
Yeah. Why go to all this trouble?
Well, they argue that to truly collaborate with humans, robots need a much deeper understanding of the world.
Okay.
They can't just follow instructions. They need to be able to perceive, interpret, and respond to their environment in a more nuanced way.
So it's not just about building a robot that can do things. It's about building a robot that can understand things.
Exactly.
It's a big difference.
It is, and that's where it gets really interesting from a technological standpoint.
Okay. So what kind of technology are we talking about here?
Well, they propose to use some really cutting-edge technologies. For instance, the vision system wouldn't just be about capturing images. It would use sophisticated algorithms for object recognition.
Oh, wow.
So the robot wouldn't just see a chair.
Right.
It would understand that it's a chair, what it's for, and how a human might interact with it.
So it's not just data, it's understanding.
Exactly.
That's impressive. What about hearing?
For hearing, they're proposing to use auditory processing that goes beyond just detecting sound waves. The HR would have what's called directional awareness.
Oh,
I
interesting.
mean, it could pinpoint the source of a sound.
Wow. So the robot wouldn't just hear a loud noise?
Yeah.
It'd be able to tell where it's coming from and maybe even what's making that noise.
That's right. And this is crucial for navigating, complex environments, working alongside humans safely, all of that.
That's incredible. What about touch? How do you give a robot the sense of touch?
Well, they're talking about equipping the HR with sensors in its skin that can detect pressure and force.
Oh, wow.
So imagine the robot not only being able to grasp an object, but also understand how much force is being applied.
That's really delicate.
It is, and it would be essential for tasks that require a delicate touch.
For sure. Or even for just interacting safely with humans.
Absolutely.
This is all very impressive. But I have to admit, the idea of a robot that can smell is a little bit mind-boggling.
Yeah.
Why is smell even necessary for a robot?
Well, think about the information that your sense of smell gives you. It can alert you to dangers like fire or gas leaks, right? So they propose to use olfactory sensors to detect specific chemicals in the environment, which could be invaluable for a variety of applications, whether it's safety or even tasks that require identifying, subtle differences in sense.
Okay.
Think about like a quality control situation.
That makes sense.
Yeah.
So it sounds like they're pulling out all the stops when it comes to sensory input, but all that information would be useless without a pretty powerful brain to process it.
Right.
What's the plan for the HR's AI?
That is where things get really revolutionary. They're not talking about your traditional AI models. They're talking about what's called neuromorphic AI.
Neuromorphic AI. Okay.
Essentially, they want to build an AI system that functions more like a human brain,
Oh,
using something called spiking neural networks, which are much more like the way real neurons communicate with each other.
spiking neural networks. That sounds intriguing. How are they different from the neural networks that, we hear about all the time?
Well, traditional neural networks can be very powerful, but they're also very energy intensive. They're like a supercomputer running at full speed all the time.
Yeah.
Spiking neural networks are more like the human brain. They only fire when they need to,
Oh, that's interesting.
making them far more efficient.
Wow.
And they're also incredibly adaptable, able to learn and change in response to new information.
So they're basically saying they want to build a robot brain that's not just a computer, but a learning, evolving system more like our own brains.
Exactly.
It's a pretty bold claim.
It is bold, but that's what makes this proposal so groundbreaking.
There's
If they
something-
can pull it off, it would be a major leap forward.
It would change everything.
It really would.
Okay, so they have this vision of a robot with human-like senses and a brain that can process information and learn like ours. But how do they actually plan to make this happen?
Well, the proposal lays out a very specific roadmap for development, and it's based on 5 core objectives.
5 objectives.
Yes, and these objectives build upon each other. They create a very clear path for the development of this advanced HR.
Okay, so it's a step-by-step plan to get to this amazing final product.
Exactly.
What's the first step on their roadmap?
Objective 1, they call it the foundation of perception. And it's all about building that incredible sensory suite we've been discussing.
Right.
Giving the HR the ability to see, hear, touch, and smell its surroundings in a way that mimics human perception.
Okay.
Without this foundation, the robot wouldn't be able to effectively interact with its environment at all.
It's like giving the robot the tools it needs to understand the world around it. So what's next on their list?
Objective 2 is what they call the thinking engine. And this is where they really dive into the development of the HR's AI brain.
Okay.
Remember those spiking neural networks we talked about?
Yeah.
This is where they come into play. The goal is to create an AI that can process that flood of sensory data in real time, make decisions, and even predict what might happen next.
So the robot could see a ball rolling towards it, hear a child shouting, and instantly know to move out of the way.
Precisely.
That's amazing.
That level of real-time processing and decision-making is really what would set this HR apart.
Okay, I'm starting to see how all these pieces fit together. What's objective number 3?
Objective 3 is all about interaction. They call it bridging the gap human-robot collaboration.
Okay.
And this is where they focus on designing a control system that allows for seamless and intuitive interaction between the HR and humans.
Hold on, a robot that can seamlessly interact with humans. How is that even possible?
Well, this is where the power of AI and machine learning really come in. By observing and analyzing patterns in human behavior, the HR's AI could learn to anticipate human actions and respond accordingly.
So it's like having a mind-reading robot.
In a way, yes. Imagine a robot that can hand you a tool before you even realize you need it.
That's the next level stuff.
It is. It really is pushing the boundaries of what we thought was possible.
Okay, what about objective 4? Where do they go from there?
Objective 4 is called the neuromorphic advantage, and this is where they focus on integrating that neuromorphic processing model we discussed earlier. Remember, those spiking neural networks are not only fast and adaptable,
Right.
but they're also incredibly energy efficient.
So this robot could potentially operate for a really long time without needing to be recharged.
Exactly. That would be a huge advantage for real-world applications.
What's the final objective, the grand finale of this ambitious project?
Objective 5 is all about putting the HR to the test, they call it, from simulation to reality, real-world validation.
Okay.
And this is where they plan to take the HR out of the lab and into the real world, testing its capabilities in a variety of environments and scenarios.
So manufacturing, healthcare, even crisis response.
Precisely. They want to see how it performs in real-life situations.
It's like giving the robot a final exam to see if it can live up to all the hype.
Exactly.
This all sounds incredible, but I'm curious to know more about Dr. Neymotin, the mastermind behind this proposal.
Yeah, he's a fascinating figure. His background is really impressive. He has a very deep understanding of computational neuroscience.
Computational neuroscience. So he's not just a robotics expert, he's a brain expert too.
Right, which makes perfect sense given the whole focus on building an HR that mimics human perception and learning.
Yeah, let's dive into his background a little bit more.
Yeah, I think that's a great place to pick up next time.
Okay, sounds good to me.
Yeah, so Dr. Neymotin's work is especially relevant here. He hasn't just been studying the brain, he's been building computational models of it.
So not just theoretical knowledge, but actual hands-on experience creating virtual brains.
Exactly. His publications show that he spent years developing these incredibly detailed computer models that simulate the activity of neurons and how they interact within neural circuits.
It's like he's creating a digital map of the brain.
Right. That's a great way to put it. And the really fascinating thing is that these models aren't static.
Right.
They're dynamic. He can actually use them to simulate how the brain responds to different stimuli, things like sensory input or even medications.
That's incredible. So what does that have to do with building a robot?
Well, the connection is in understanding how the brain learns and adapts.
Okay.
If you can figure out how the human brain processes information, learns from experience, you can start to apply those same principles to artificial intelligence.
So that's where the link between neuroscience and robotics becomes really clear. They're trying to take inspiration from the most complex and efficient information processor we know of the human brain.
Exactly. It's biomimicry at its finest. And when you look at Dr. Neymotin's research on sensory learning, you'll see he's specifically interested in how different sensory modalities interact.
So how vision, hearing, touch, and smell all work together to create a unified perception of the world.
Precisely. It's not just about having the senses, it's about how they work together. His research suggests that the brain isn't processing each sense in isolation. There's a lot of crosstalk between different sensory areas.
Interesting. So what we see can influence what we hear, what we touch, can influence what we smell. It's all interconnected.
Exactly, and that's something that would need to be incorporated into the HR's AI. The algorithms would need to be able to integrate information from all of the robot's senses in a way that's both efficient and accurate.
That sounds like a huge challenge.
It is a major challenge, but one that Dr. Neymotin seems well equipped to tackle.
Are there any other areas of his expertise that are particularly relevant to this project?
His CV also highlights his work with something called reinforcement learning.
Reinforcement learning, what's that?
It's a type of machine learning that's really effective for teaching robots how to perform complex tasks.
Okay, so is it anything like how we train pets? Good robot, you put the block in the right slot, here's a digital treat.
Yeah, that's a great analogy. The basic idea is that the robot receives rewards for performing actions that lead to a desired outcome.
I see.
And Dr. Neymotin has actually used reinforcement learning to train computer models of the brain to perform virtual tasks.
Wow, so he's already got experience teaching virtual brains new tricks. The experience would certainly come in handy for teaching this HR how to interact with the real world.
Exactly. They could use reinforcement learning to teach the robot everything from basic movements to really complex tasks, even things like how to work collaboratively with humans.
It's fascinating to think about how all this cutting-edge research is converging to make this project a reality. Dr. Neymotin's background seems perfectly suited to tackle this challenge.
And it's not just his technical expertise that's valuable. His CV also shows a strong history of collaboration working with researchers from all over the world.
Yeah, this is definitely too complex for any one person to take on. It requires a team effort.
Absolutely, bringing together the best minds from different fields.
Which brings us back to the heart of this proposal, the 5 core objectives they've laid out to achieve their vision of a truly collaborative humanoid robot.
Right, we've talked about the first 4, building the sensory systems, developing the AI, ensuring seamless human-robot interaction, and leveraging the efficiency of neuromorphic AI.
Now it's time to talk about Objective 5. From simulation to reality, real-world validation.
This is where the rubber meets the road. They're not just theorizing, they're planning to put this HR through its paces in real-world settings.
So they're taking this robot out of the lab and into the wild. Where are they planning to test it?
They've identified 3 key areas: manufacturing and logistics, healthcare, and emergency response.
Let's start with manufacturing and logistics. What role would an HR play in that setting?
Imagine an HR working alongside human operators on a factory floor, assisting with assembly quality control, or even handling hazardous materials.
I can definitely see how a robot with those advanced sensory capabilities and a sophisticated AI would be a huge asset in that kind of environment.
And that ability to predict human actions would be really valuable. It could anticipate the needs of its human coworkers, fetching tools and materials before they're even requested.
It's like having a super efficient mind-reading assistant right there by your side. It sounds like it could significantly improve both productivity and safety in the workplace.
Exactly, and those are key considerations in any manufacturing environment.
What about healthcare? That's an area where the human touch is so important. How would an HR fit in there?
That's a great question, and it's important to remember that these HRs wouldn't be replacing human caregivers.
Okay.
They'd be augmenting their abilities, working alongside them to provide even better care.
Okay, so how would that work in practice?
Well, imagine an HR assisting a surgeon during a complex procedure. Its steady hands and precise movements would reduce fatigue for the surgeon.
Okay.
And its advanced sensory capabilities could actually provide real-time feedback during the operation.
It sounds like a game changer for surgery, especially for those really delicate procedures that require incredible precision.
Absolutely. And beyond the operating room, HRs could provide physical therapy, monitor patients' vital signs, or even offer companionship to those who are isolated. That ability to communicate and understand human emotions would make them ideal for those roles.
It seems like their potential applications in healthcare are really diverse.
Mm-hmm.
What about emergency response? That's a high-stakes environment where every second counts.
Exactly. And the proposal highlights the potential for HRs to be deployed in situations that are just too dangerous for humans.
Right, like a burning building or a natural disaster zone.
Precisely. Think about a hazardous material spill or a collapsed mine.
So they could be like robotic first responders going into assess the situation, locate survivors, and even begin rescue operations.
That's right. Their advanced sensory capabilities would allow them to see through smoke, hear faint cries for help, navigate treacherous terrain. They could even relay crucial information back to human responders in real time.
It's a pretty remarkable vision of how these robots could be used to save lives.
It really is. And these three examples, manufacturing and logistics, healthcare, and emergency response, they really highlight the transformative potential of this project.
Absolutely, and it seems like we've only just scratched the surface.
Yeah, we have. There are a lot more potential applications outlined in the proposal.
I'm curious, what else do they mention? Where else could these HRs make a difference?
Yeah, so we've talked about how these HRs could really shake things up in manufacturing, healthcare, and even emergency response, but it sounds like this proposal doesn't stop there.
Oh, no, not at all. They've got a whole laundry list of potential applications.
Okay, give me some examples. I'm really curious now.
Well, they talk about space exploration education, even things like defense, hospitality, customer service.
Wow, okay, so space exploration. I mean, robots already play a big role there, but I can see how an HR with, human-like senses and AI could really take things to a whole new level.
Or absolutely. Imagine these HRs working alongside astronauts, assisting with maintenance tasks on the International Space Station, maybe even conducting experiments.
Yeah.
Their ability to operate in a weightless environment, withstand extreme temperatures, perform those really delicate tasks.
Yeah.
I mean, it would be invaluable.
And their AI, it could allow them to adapt to unexpected situations, make decisions independently, which would be really crucial in that unpredictable environment of space. Yeah, exactly. It's like having a highly skilled, adaptable assistant no matter where you are in the universe.
What about education? How could these HRs change the way we learn?
Well, they could act as personalized tutors, adapting their teaching methods to each student's individual learning style.
So a robot teacher that's infinitely patient.
Right. And always knows the best way to explain something.
That could be amazing for students who need a little extra help.
And their ability to demonstrate concepts and skills in a hands-on way. I mean, that would be huge, especially in fields like science and engineering.
Yeah, that makes sense.
Okay,
so we've got space exploration, personalized education. It seems like these HRs could have a really positive impact. But what about some of the more sensitive fields like defense and security?
Yeah, those are definitely areas where the ethical implications need to be very carefully considered.
For sure.
But the proposal does suggest that these HRs could play a really valuable role in protecting human lives.
Okay, so for instance.
Well, think about bomb disposal, hostage rescue, or even peacekeeping missions.
Right, high-risk situations.
Exactly, situations where human lives are on the line. And HR could be sent in to assess the situation, gather information, even take action to neutralize a threat without putting human lives in danger.
It's like having a robotic guardian angel always watching out for human safety.
Yeah, that's a really interesting way to put it. And then they also talk about some more everyday applications, like I mentioned, hospitality and customer service.
Oh, wow. Okay, now that's interesting. I wouldn't have immediately thought of that as a place for humanoid robots.
Yeah, it might seem a little surprising at first, but think about the tasks involved, greeting customers, providing information, assisting with luggage room service. I mean, these are all tasks that an HR could perform potentially with a lot of efficiency and even a touch of charm.
I can imagine walking into a hotel and being greeted by a friendly, helpful robot that can answer all my questions in any language. I mean, it would definitely change the customer service experience.
And it wouldn't just be about efficiency. These HRs could be programmed to be incredibly patient, polite, even empathetic, which could lead to a much more positive experience for customers and employees alike.
It sounds like they've really thought about the human element in all of this.
They really have, and that's what makes this proposal so compelling. It's not just about building robots. It's about building robots that can work alongside us in a way that benefits everyone.
This entire deep dive has been incredibly thought-provoking. It's exciting to imagine a future where robots are not just tools, but partners, working alongside us to solve problems, make our lives easier, maybe even push the boundaries of human potential.
It's a future filled with possibilities, but also a future that demands careful consideration. As these technologies continue to develop, it's really important to have those open and honest conversations about their impact on society, the workforce, even the very nature of what it means to be human.
Yeah, that's a really great point. We need to approach this new era with both enthusiasm and caution, always prioritizing human well-being, making sure these technologies are used for good.
Absolutely, and it's a conversation that everyone needs to be a part of.
Well said. This has been an incredible journey into the world of humanoid robots, and I'm left feeling both excited and inspired.
Me too. It's a real testament to the power of human ingenuity and the boundless potential that's out there when we combine our creativity with these incredible capabilities of technology.
Well, thank you for joining us on this deep dive into the future of humanoid robots. Until next time, keep exploring.